Okay, let's dive into what has to be the most mind-bending thought experiment in all of physics. I want you to close your eyes for just a second. Imagine you're floating out there in deep, peaceful, utterly silent space. The stars all around you just look like scattered grains of salt on this massive black tablecloth. Your spacesuit is humming gently in the background, keeping you perfectly safe, even though you are hovering right on the edge of literally the most hostile environment in the entire universe. You feel completely weightless, you feel peaceful, you feel almost free. But then I want you to imagine looking down, and what you see is actual nothingness. And I don't mean like an empty room or a dark hallway at night. I mean a circle of absolute darkness that is so complete your brain just fundamentally struggles to process it. There is absolutely no light escaping from this thing. There are no signals leaving it. No information whatsoever comes back from whatever crosses its edge. You are staring down a black hole and you are drifting straight toward it. What happens next is without a doubt one of the most terrifying, beautiful, and totally reality-breaking journeys that physics can possibly describe. Now, before we just toss you in there, we really need to understand exactly what it is you are falling toward. Right at the very core of all that darkness is what physicists call a singularity. It is this infinitely small, infinitely dense point where every single bit of the black hole's matter is completely crushed. The gravity here is so unimaginably strong that all of our current, beautifully, mathematically proven laws of physics just completely fall apart and break down. Surrounding that terrifying little core is the event horizon. You've probably heard the term. This is the invisible boundary that acts as the ultimate cosmic point of no return. It's not a physical wall, right? It's not a solid barrier you'd bump into. Instead, it's just the exact mathematical perimeter where the fabric of space itself bends inward so steeply that every possible path forward just leads deeper inside. Not even light, which is literally the fastest thing in the universe, can escape its pull once it crosses that invisible line. So how do these dark monsters actually get here? It's a fascinating process. It all starts with a massive star burning through its hydrogen and helium for millions and millions of years. And all that intense burning creates this massive outward pressure, kind of like air keeping a balloon totally inflated. But eventually, inevitably, that fuel completely depletes. And when it does, that outward pressure just stops, completely. And that exact moment, gravity wins the tug of war. The star completely collapses inward on itself with this unimaginable force, crushing all of its massive bulk into that tiny singularity. Let's really try to visualize this. Think of a giant trampoline. If you take a heavy bowling ball and place it right in the center, the fabric naturally sags down. We're all familiar with that analogy for gravity. But a black hole isn't just a heavy bowling ball sagging the fabric of space. No, it's an object so incredibly, mind-bogglingly dense that it doesn't just sag the trampoline, it literally tears a hole right through the fabric, creating a pit that is so incredibly deep that anything rolling anywhere near it falls in and never, ever comes back out. Section 1. The Edge of No Return. Let's officially begin our descent into the void. To really grasp this approach, imagine you've left a partner behind in a spaceship, hovering at a nice, safe distance just to watch you fall. Initially, your approach actually feels shockingly gentle. You aren't feeling some sudden violent pull, you aren't hearing some massive roaring sound in your ears. But visually, things are starting to get incredibly weird. The stars directly behind the black hole begin to warp and stretch out. Because the immense gravity is literally bending the light of those distant stars, it looks exactly like you're staring through the curved bottom of a really thick glass bottle. Stars that should absolutely be hidden behind the black hole suddenly become visible as their light curves all the way around the darkness. It's this insane funhouse mirror effect, and astrophysicists call it gravitational lensing. Because of all this extreme bending of light, you'll suddenly see this hauntingly beautiful ring of totally distorted light just surrounding the absolute darkness. We call this the photon sphere. This is the exact region where light itself actually gets trapped in an endless orbit around the black hole. Seeing this glowing, chaotic ring of trapped light is basically your very first physical warning sign that all the normal rules of reality are about to completely shatter. And here is where time itself starts playing some massive tricks on you. Thanks to Einstein's theory of relativity, we know for a fact that extreme gravity fundamentally slows down time. From your perspective, as you're falling in, time just ticks away normally. Your heartbeat is steady, your watch ticks by the second, and actually crossing that event horizon is totally smooth and uneventful. You wouldn't even feel a bump. But from your partner's perspective, sitting safely back in that spaceship, they are seeing something completely different. They literally watch your movements slow down until you freeze. The light bouncing off of you stretches out, shifting your image to a deep red, and you just slowly fade into this frozen ghost lingering at the edge. And the craziest part, both of your experiences of time, even though they totally contradict each other, are mathematically and physically valid. Section 2. The physics of spaghettification. So we finally reached the part of the explainer that literally keeps astrophysicists up at night. We have to talk about the deeply terrifying realities of human biology meeting extreme unrelenting gravity. The key concept we really need to take our time with here is something called tidal forces. Think about it. As you fall in feet first, your feet are technically slightly closer to the center of the black hole than your head is. Because the gravity is so extreme, it pulls on your feet vastly harder than it pulls on your head. The difference in that gravitational pull over just the length of your body becomes enormous. It physically pulls you apart, stretching you vertically and compressing you inward horizontally. Physicists, possessing a wonderfully dark sense of humor, officially call this horrifying biological stretching process spaghettification. But here's where it gets really counterintuitive. Look at how this fate changes depending entirely on the size of the black hole. If you happen to fall into a smaller, stellar mass black hole, those tidal forces ramp up so violently that you are instantly spaghettified into a ribbon of subatomic particles well before you even cross the event horizon. It's just instant destruction. But if you fall into a supermassive black hole, the giant ones with the mass of millions of suns, it actually grants you a surprisingly gentle crossing. The event horizon is just so far away from the singularity at the center that the tidal forces there are weak. You'd actually get minutes, maybe even hours, of totally peaceful falling inside the horizon before that fatal stretch finally catches up with you. Section 3. Inside the conveyor belt. Let's just assume for a second that you've survived the crossing into one of those supermassive black holes. What actually happens now? Well, this is the exact moment where honest physicists have to raise their hands, take a step back, and admit we are now entering the realm of pure mathematical theory. According to general relativity, once you are inside the event horizon, space itself acts like a one-way conveyor belt, carrying you inexorably forward. Every single possible direction you could point your ship towards now leads directly to the singularity. And here's the real mind-bender. Mathematically, this means the singularity is actually not a physical place in space that you are falling down toward. It has become a moment in your future time. Just like you literally cannot avoid moving forward into next Tuesday, reaching the singularity is now a mathematical inevitability. And man, what an unbelievable view it would be as you ride that conveyor belt toward the end of your time. If you were to look back up, the math suggests all the light from the outside universe pouring in behind you would get intensely compressed and blue-shifted. Because space itself is flowing inward faster than the speed of light, it's theorized you might actually witness the entire future history of the universe play out. Every star forming, every galaxy slowly dying out, all playing out in a brilliant compressed flash of light right above your head. Assuming, of course, that the intense radiation from all that compressed light doesn't completely vaporize you first. Section 4. The ultimate unknown. Because eventually, no matter how long it takes, that conveyor belt reaches its end. And when you finally hit that singularity, Einstein's beautifully elegant general relativity completely throws up its hands and quits. The equations literally spit out impossible infinities, infinite density, infinite curvature. Whenever math gives you an infinity, it's nature's way of telling physicists that our theory is incomplete. It's screaming at us that we desperately need a brand new theory of quantum gravity to explain what actually happens when the physics of the extremely massive violently collides with the physics of the extremely microscopic. Because our current math totally breaks down at this exact point, it leaves the door wide open for some deeply wild sci-fi level possibilities. Some highly speculative mathematics suggest the interior of a black hole might act kind of like a cosmic bathtub drain, connecting via an Einstein-Rosen bridge, which we usually just call a wormhole, to a faucet in some entirely different universe. Other physicists hypothetical about white holes, which are basically timer-first black holes that explode matter outward instead of pulling it inward. There is even a very serious mathematically debated hypothesis that our own universe's Big Bang was actually born from the collapse of a black hole inside a much larger, older parent universe. Section 5. The information paradox. Now, this next concept, brilliantly discovered by Stephen Hawking in the 1970s, reveals just how deeply these objects challenge the absolute core foundations of quantum mechanics.
See, Hawking famously discovered that black holes aren't actually entirely black. They slowly leak energy. They emit this incredibly faint glow over trillions and trillions of years, which we now call Hawking radiation. And eventually, they evaporate completely into nothing. But here is the massive problem. Quantum mechanics has a very strict, unbreakable rule. Information cannot ever be destroyed. So, if the black hole eventually disappears entirely, where does all of the information go? The data that made up your body, your memories, the specific arrangement of your atoms? This single question has sparked a fierce, 50-year-long debate among the smartest theoretical physicists on the planet. One of the most mind-bending solutions proposed recently is called the holographic principle. It suggests that, wait for it, you don't actually truly disappear or get destroyed when you fall in. Rather, all the quantum information that makes up you is essentially smeared out and permanently preserved across the two-dimensional surface of the event horizon itself. Kind of like binary data saved on a computer's hard drive. In this completely wild view of reality, the entire 3D experience inside the black hole is really just a holographic projection of that 2D surface data. It completely redefines what reality even is. To try and put all of this extreme reality-bending physics into some kind of perspective, just look at this number for a second. 4 million. That is the number of suns worth of mass sitting right at the center of our very own Milky Way galaxy. All of it compressed into a supermassive black hole that we call Sagittarius A star. It is 26,000 light-years away from us, and it is just sitting there, quietly shaping the entire evolution of our galaxy, warping time and bending space right this very second. Ultimately, what I absolutely love about exploring this topic in this explainer is that these cosmic monsters truly humble us. They aren't just destructive holes out there in the dark, they are really mirrors, and they are reflecting the absolute limits of human understanding right back at us. They completely shatter our basic, comfortable, everyday assumptions about the steady flow of time and the fixed, permanent nature of space. They force us to confront just how deeply strange and complex reality actually is. So, as we wrap things up here, I just want to encourage you to keep looking up. Keep asking these massive, impossible questions. The universe is under absolutely no obligation to make sense to any of us, but your curiosity, your willingness to imagine yourself falling headfirst into the great unknown, that is easily one of the most beautifully human traits you possess. So I'll leave you with this final thought. If the universe really is this much stranger than we ever thought possible, what other impossible realities are just waiting out there in the dark for us to discover them?